Hey everybody, so today in maths class we are gonna do the numerical that is related to the Lami's theorem. In the previous maths class video, we did the proof of the Lami's theorem. So if you didn't see that video, just check it out. You'll find the link in the top right corner of the video right now. And the statement of the numerical that we are gonna solve today says that a body of mass 26 kg is suspended by two strings. So one string is 5 centimeter long and the other one is 12 centimeter long. Their other ends being fastened to the extremities of a rod that is 13 centimeter long. So both these strings, let us just draw a rough diagram. So there is a body of mass 26 kg, let us say. So this is 26 kg and this is suspended using two strings. So here is one string that is, they are saying 5 centimeter long, and here is the another one that they are saying is 12 centimeter long. So this is a rough diagram. We are just gonna draw it roughly. And now these are the two strings, and there one of the ends is is attached to this mass of body of mass that is of 26 kg, but their other ends, now their other ends are this and this. So their other ends being fastened to the extremities of a rod that is 13 centimeter long. So let us suppose that this is a rod that is 13 centimeter long, and these are the extremities of that rod. That means the ends of that rod. Okay, so now let's see what they are saying next. If the rod be so held that the body hangs immediately below the middle point. Now this is the body that we have, and let us see where it is. Okay, it is here at this point below the rod. Now they are saying that the rod be so held that the body hangs immediately between the middle point of that rod. Okay, so this is the 13 centimeter long rod, and this may be its middle point. I am just darkening it for your convenience to see it, the difference. But the body that is hanging is not below the middle point of the rod. So that means we have to adjust the rod accordingly so that the body hangs immediately below the middle point of the rod. So for that, I would have to just erase this diagram and draw it again. Oh, give me 1 second. Now you can clearly see that I have drawn the diagram such that the body of 26 of mass 26 kg that is hanging, it is hanging below the middle point of this rod that is of 13 centimeters long. So to make it easy for us, let us assign some alphabets to the points. Let this point from where the body of mass 26 kg is hanging with the help of two strings, let this point be called O, and let this point be A, and this point be B point. So now we have a rod AB of 13 centimeter, and there are two strings OA and OB that are of 5 centimeter and 12 centimeters respectively. So now we have also done this situation, and now what we have to do is find the tensions of the strings. So let the tension that is in OA string be T1, and the tension that is of OB string, it be T2. So these are the two tensions, and now we have to find the values of T1 and T2. Okay, and now also let us say that this is the point D. So D point is the middle point of the rod AB. So now you can clearly see that this OA, it is equal to 5 centimeter, OB, it is equal to 12 centimeter, and this AB, it is equal to 13 centimeter. So if we do the square of AB, then it would be 13 square, and this would be equal to 169. And if we do the square of OA, then it would be 5 square, and that is equal to 25. And if we do the square of OB, then it is 12 square equal to 144. And if we now add the squares of OA square and OB square, then this is equal to this 25 plus 144, 25 plus 144, and that equals to 169, and which is the square of AB square, which means that OA square plus OB square, this is equal to AB square. So as we can see that the square of one of the sides of this triangle OAB, so the square of one of its sides is equal to the sum of the squares of its other two sides. So by converse of Pythagoras theorem, we can say that this AB side, this is the hypotenuse. So if this is the hypotenuse, the angle that is opposite to this AB side, what angle is it? This angle. This must be 90 degree. Are you getting me? That by converse of Pythagoras theorem, we get that this angle, that is AOB, this angle, it is equal to 90 degree. Now we know that this D point, it is the midpoint of this hypotenuse AB. So in a right angle triangle, there is a property that the point that will be the middle point of the hypotenuse, it will be equidistant from the vertices of the right angle triangle. So now this is the D point, it is the middle point of the hypotenuse, which means it is from equal distances from all the three vertices of the right angle triangle, and the vertices are A, O and B, which means this distance, that is DA, and this distance, that is DB, and this distance, that is DO. All these distances are same, this DA, DB and DO. That is to say that the midpoint of hypotenuse is equidistant from the three vertices of a right angle triangle. So let us just say that DA is equal to DB is equal to DO as, let me just write fast, midpoint of hypotenuse is equidistant from the three vertices. So now let us suppose that this angle that we have here, this one, what we will call it angle OAB. So this angle OAB, this is equal to theta. So let this angle be theta. Now we know that this D in this triangle OAD, this DA is equal to DO, as we have here, DA is equal to DO. So these are the equal sides. So now we know a property that the angles that are opposite to equal sides are also equal. So now I'm not gonna write it to waste your time. I'm just gonna say it to you. So just listen carefully. The property, it is that the angles which are opposite to the equal sides are also equal. Okay, so these are the two equal sides. And what is the angle opposite to this side? This angle. And what is the angle opposite to this side? This angle. So these are also equal, which means that this angle is also equal to theta, angle AOD. Okay, so I hope that you have got the point. I'm not gonna write it. So if this is theta, we know that this whole angle, angle AOB, this angle is equal to 90 degree because this is a right angle triangle. So if this is theta, this must be 90 minus theta. This angle, angle DOB, this will be equal to 90 degree minus theta. So that is how the sum of these angles will came 90. So this is theta and this is 90 minus theta, and this whole angle is equal to 90 degree. Now again, if you see that in this triangle DOB, we have two equal sides. They are DO and DB. DB is equal to DO. So these are two equal sides. So then again, the angles that are opposite to the equal sides of a triangle must also be equal. So if this angle is 90 degree minus theta, this angle, this DBO angle, this also must be equal to 90 degree minus theta. Now we have found what these angles are, but why we are finding what these angles are? What is our motive? Our motive is to find the values of this T1 and T2. So how we will find it? By using Lami's theorem. So now let us just use Lami's theorem and try to find what these values are of T1 and T2. So as you can see that this T1 force, it is acting along this direction, and this T2 force, it is acting along this direction, and this 26 kg, it is acting along this direction, which means that these three forces are acting at this point O and are in equilibrium. So let us just write it down. Since forces T1, T2, 26 kg acting at O are in equilibrium, then by using Lami's theorem, what did the Lamy theorem state? It states that if three non-collinear forces acting at a point are in equilibrium, so these are the three non-collinear forces T1, T2 and 26 kg, these are acting at a point O and are in equilibrium, then each is proportional to the sine of the angle between the other two. I repeat that if you do not know how the proof of this Lamy theorem came, then you could just watch my previous maths class video. In that I have shown you how it has been proved. So these are the three forces that are acting at a point O and are in equilibrium. Then each will be proportional to the sine of the angle between the other two. Now let us first consider this force T1. Okay, so now what are the two other forces? This T2 and 26 kg. And what is the angle between them? This angle. This is the angle that is between the forces T2 and 26 kg. And now we would have to find out the value of this angle so that we could put sine in front of it, and then we could just write down the equation that we are getting by using Lami's theorem. So we know that this is a line, this, and this angle is 90 degree minus theta, and we have to find this angle. So why not use the linear sum property, which means that this angle, this might be, I am just writing in rough, this might be equal to 180 degree minus this angle that we have, and this angle is 90 degree minus theta, because the sum of these two angles will be equal to 180 degree. So this is what linear sum property says. So this angle must be equal to this 180 degree minus this 90 degree minus theta. So definitely it would be equal to 180 degree minus 90 degree plus theta when we will remove the bracket, and 180 degree minus 90 degree, it would be equal to 90 degree, and then this we have plus theta with us. So this angle, I am gonna write it here, its value is 90 degree plus theta. So this is between the forces T2 and 26 kg when we are considering the force T1. So definitely in denominator, the sine of which angle will be there? 90 degree plus theta, which is the angle between the other two forces. Okay, so now this will be equal to T2. So now we are considering T2 and sine of the angle we would have to find. So this is the T2, and what are the other two forces? T1 and 26 kg, and what is the angle between them? This angle. So now we would have to find the value of this angle. Since we know that this angle is theta, and then the sum of this angle and this angle must be 180 degree due to the linear sum property. So definitely what would be the value of this angle? 180 degree minus theta. Are you getting it? If you do not understand, feel free to comment me in the comment section to ask me what you are not getting. Okay, so now here would be sine of 180 degree minus theta, and the next our force is 26. Okay, and now the two other forces are this T1 and T2, and what is the angle between them? This 90 degree angle. Okay, so now we are just simply gonna write it sine 90 degree. So this is the equation that we get by using Lamy's theorem, and by this equation only we are gonna find the values of T1 and T2. So as we know that this T1 upon this sine 90 degree plus theta. So 90 degree plus, it means it would be in the second quadrant, and in second quadrant sine is positive. So definitely the sign that we would have, it would be positive, and because it is the 90 degree, so definitely the sign would convert into cos, and the value of this angle would come cos theta. And next we are having sine 180 degree minus theta. So it is 180 degree minus, which means it is again the second quadrant, and in second quadrant the sign is positive, which means the sign that we would have would be positive, and because it is 180 degree, the sign will remain as sine. Okay, so now this would be sine 180 degree minus theta would be equal to sine theta. And now 26 upon what is the value of sine 90 degree? It is 1, which means now if we are equating this T1 upon cos theta, that is equal to 26. I'm just gonna say 26 because 26 upon 1 is equal to 26. So now we would say that this T1 would be equal to this cos theta, it would be multiplied by 26. So this T1 would be equal to 26 into cos theta. And similarly, if I am equating these two equations, that T2 upon sine theta is equal to 26, then this T2 would be equal to 26 into sine theta. So now we have almost find out the values of T1 and T2. We just need to find out the values of sine theta and cos theta and then put it in these equations, and then we would find the T1 and T2. So without wasting any time, let us find out the values of sine theta and cos theta. Okay, so let us suppose that we have this triangle AOB. So in this triangle, this A angle, it is theta, we know, and this AB, it is the hypotenuse. So if we have this angle theta, then this OA would be the base and this OB would be the perpendicular. And sine theta, I am just gonna write it here in rough. We know that this, it is equal to perpendicular upon hypotenuse. So now what is the perpendicular? This OB, and what is its value? This 12 centimeter. So it is 12. And what is the hypotenuse? This AB, and its value is 13. So sine theta is equal to 12 upon 13. Now similarly, let us find the value of cos theta. Cos theta is equal to base upon hypotenuse. So what is the base? This 5 centimeter OA side. So 5, and again the hypotenuse is 13. So these are the values of sine theta and cos theta. Let us just put and find the values of T1 and T2. Okay, so now we have that T1 is equal to 26 into cos theta, which means 26 into, what is the value of cos theta? 5 upon 13. So let us just put here 5 upon 13. So 13 plus 13 is 26, which means that when we will cut, here will come 2, and this will be equal to 2 into 5, 10. Okay, and this T2 is equal to 26 into sine theta. So what is the value of sine theta? This 12 upon 13. So 12 upon 13, and again when we will simplify it, so this will be 2 into 12, and this will be equal to 24. Let us not forget that with here we have 26, but we have its unit kg also. So the unit of these tensions T1 and T2 would also be 10 kg and 24 kg respectively. So we have find out the values of the tensions of these strings T1 and T2. So I hope so that you would have clearly understood how this numerical has been solved by me. If you have any doubt, you can just ask me. So that's for today. Goodbye, everybody.